like how much you can do with prompt engineering.
Hello, everybody. Thanks for joining us again in another episode of Humans of Digital. Again, we're doing an AI talk here. And my name is Rodrigo. I've been director of engineering for CI&T for the past years. And for the past year and a half or something, I've been really delving into the AI world. So I'm still learning a lot, but I'm happy to have a few folks here with me that knows a lot more than I do. So I'll ask them to introduce themselves. Mika, can you go next?
Yeah, sure. So my name is Mikaeri. I work together with Rodrigo here at CI&T, building a Gen AI platform. I'm AI machine learning leader here at CI&T, and I'm also a GD machine learning. That's why and where I met Sayak, one of our colleagues here, talking to us about Gen AI. So Sayak, very happy to have you here with us. Please introduce yourself.
Yeah, I'm really glad to be here. Well, it's first of all, it feels amazing to be able to talk to friends from Brazil, because in India soccer is really a big thing, and we all grew up, seeing football matches of Ronaldinho, and so on. So it feels really special. I'm not gonna make any faces in admitting that, but it does feel really special. Now coming to who I am, I work as a machine learning engineer at Hugging Face. More specifically, I work on areas like image generation, video generation, and parameter efficient fine tuning. But I have had the opportunity to work on many different facets of machine learning, like small scale language models back in my previous employer, then also model optimization for a fair bit, MLOps, large scale data engineering pipelines, and so on. So pretty cool stuff. And ML is literally all I have done throughout my professional career. And that's what I would like to do, at least for the next 10 years. But yeah, very passionate about the field and really like the challenges that come with it. And yeah, I'm all in for the good and the bad of the field. It's not like every day needs to be about the good things. So yeah, all in.
It's very nice to hear that you are happy to talk to us from Brazil. Now you have to come here, as I mentioned in the last event that we had here.
I will.
In Singapore, remember? So nice. And it's very interesting to know, Sayak, that you work with a lot of different branches in the ML area, because we know that it's very, very huge area that we have, right? So you decide to work with ML, and then you had to decide, okay, what are the specific parts that we have to focus, right? And one of the things that you mentioned is about MLOps, right? So MLOps is, to be honest, is the area that I like the most, because I'm a former engineer, almost an C# architect. So when I was working with more focus in the engineering part, and I decided to move to machine learning, I thought that I would lose all of the things that I learned as an engineer, like Docker, Kubernetes, all of this stuff. And then MLOps comes to the table, showing us that this is very important as well. And you can merge this with linear algebra, and it can be powerful for our work life, right? So, but this is a challenge, right? There's a huge challenge, because, okay, you create our models, and then you have to move that to production. And when we work with large language models, or even before with just language models, right? It's already challenging, because you have to balance a lot of different things, and then a bug can come out to us, and you have to understand, okay, where is it coming from? Is it from data? Is it from the model? Is it from, I don't know, maybe it's a model drift, data drift. So about this challenge specifically, have you faced some of them during your career? Can you show us a little bit how you overcame them?
I think I faced challenges in various aspects. Like in my previous organization, we were dealing with a lot of, e-commerce data, but on the internet scale. Imagine having to work with billions and billions of e-commerce product websites. So there was my first challenge, right? Because how do you deal with such a large volume of data, right? Like before even building the model, you need to first represent the data in a very salient way and think about the problems that can be solved using machine learning, because you can't throw any problem at the face of a machine learning model and just be satisfied with it, right? You wouldn't want to solve Fibonacci number series with machine learning. You really need to have the right mindset to decide, okay, this is a problem that could really benefit from machine learning, and my organization could optimize some north star metrics if we decide to solve this problem using machine learning. So there has to be some level of maturity. So when I joined my previous organization, it's called Carted. It was into e-commerce, and we really had to think hard as to how to go about setting up the problem statement in the first place. Like, what are some of the immediate problems that we could have solved using machine learning and with all the data that we had in our inventory, right? And then once we had a somewhat clear understanding of the problem that we could solve, we had to deal with the data part, right? It was like unstructured, semi unstructured, I would say, semi unstructured piles and piles of product e-commerce data continuously being populated. It's not like we have a huge pile, it's not gonna get updated over a period of 3 months. It's getting crawled, it's getting indexed like each and every day. So I was like, how do I deal with this level of data? So we had to do a fair bit of engineering, like representing a product e-commerce website is a challenging part itself. And the problem that we were trying to solve is like building. It was about building a universal attribute extraction model. Like I'll try to simplify the problem statement. Given a product e-commerce website, can your model predict which HTML parts in your website will lead to a particular product attribute, like product title or product description or product measurements or dimensions and so on? Now the second question we got asked from the leadership is like, can't you do this with beautiful soup, like clever parsing algorithms and stuff like that? But the thing is, all of those all of the logic for that would be pretty heuristics driven. Like, layouts of HTML pages can change all the time. So that's why we wanted to have a model that could understand how HTML structures are represented, leveraging the tree like structures that usually the HTML pages have in their layout inherently. And since we already had the data, we decided to throw a lot of data at our simple model and see what happens. Now, okay, now that we had a somewhat clear understanding of this is how we want to proceed with these things, next part was about the data part, right? We didn't face any problems in acquiring the data, but processing such a large chunk of data as efficiently as possible, that too with the limited amount of resources that we had in our disposal, was the first challenge. And then we had to do a lot of brainstorming sessions and stuff like that. And some of the stuff that I worked on as a part of that project is actually open source. If someone wants to go to my website, they should be able to find it out. So after the data part, we had to think hard about the modeling part. Like, we had a somewhat vague understanding of how we would architect the model, but not a very clear one. Like, how do we go about representing the graph structure of the HTML page? How do we embed the textual content of the HTML page? How do we represent the positions of each of the nodes and stuff like that? And how do we even predict which HTML paths might have the attributes that we are looking for? So then after a lot of research paper reading sessions, we could come up with something. And then the next challenge was about scaling the training process using the pile of e-commerce data that we had. And fortunately enough, we didn't face much difficulties there because we kind of had prior experience in that area. Next part was to be able to operationalize that model. So the thing is, again, operationalization of a model is almost always never easy. Like it's not like a one click thing where everything is supposed to work right off the bat. It's not going to work like that. So we faced a lot of challenges like optimization and stuff like that. And once we optimized the model, we faced information loss issues, like the accuracy took quite a bit of a hit. So we had to, go approach the problem from first principles, like really seeing how the model activations were changing. If we were quantizing the model, how much the activations were changing and stuff like that, and which layers were causing the information loss. And once we were able to pin down a particular bug, it was very easy to fix. And also the parallelly we were also working on a product language model, and the reasoning behind working on a particular product language model was this. If you see the linguistics of product web pages, it's very different from how we speak in English or any other language, right? Your natural language linguistics differ a lot from what's written on the product website. So that's why we had a hypothesis that if we had a language model that was trained on our product description corpus, it would probably perform better on the fine tuning tasks, such as product category classification, then product attribution from particular product descriptions and stuff like that. So we decided to also parallelly work on a product language model, and it actually performed better on our internal evaluation suite. So in comparison to an off-the-shelf model like Robota or BERT, and this is from 2021, so GPT-4 was not around. We were still dealing with small size language models. So yeah. So in comparison to an off-the-shelf Robota or a BERT, our language model trained on the particular product corpus data that we had, it performed way better, way better on the internal evaluation suite that we had. So similarly, we faced challenges there, and since we were limited to using CPUs during inference, we had to really optimize the model so that it runs as optimally as possible on CPUs. So we didn't have the freedom of using GPUs during inference. So we had to really keep things to CPUs only as far as inference workloads were concerned. But yeah, we were able to figure things out pretty neatly, and I feel quite happy about that project. And it also gave me a lot of experience into how to go about architecting different parts of your ML project. Like if you have got large scale data, rely on things like Apache Beam and Beam pipeline runners such as Cloud Dataflow, because these things have the ability to auto scale as per your requirements. They can scale up based on the requirements. They can also scale down based on the requirements. So you do not have to manage anything. It's purely serverless, and you are basically delegating all of those responsibilities to an external cloud service provider. I think that's perfectly fine if you need to move faster and iterate faster. So yeah, it was a lot of learning, but fun at the end of the day.
Very cool. And you brought some insights on how to deal with production models, and especially you thought about you discussed about using CPU only, which is something very interesting because we and our platform, we try to play around with open source models and deploy them to a few environments. Very hard to get a hold of GPUs and the scale that we needed, right? Even for testing was kind of hard to get availability of GPUs in cloud providers right now. Everybody wants their own GPU to do stuff.
Yeah.
So how do you went about it? You said you optimized the model. What specifically elements did you tune? What did you do?
Yeah.
Or more about quantization? Did you use anything else? How was that process, and how did you come about it?
Yeah, sure. I think that was the most fun part of the entire project lifecycle. So I'll go all in. I'll go all guns blazing. So we started with our product language model, and then we fine tuned it on a couple of tasks such as product category classification, and then we had a product category classifier. Let's consider that model as our model B, which we want to deploy on Intel CPUs. So that's our premise of deployment, let's say. Now, the model was kind of bulky in size as far as our requirements were concerned. I mean, the bulkiness of a model can vary from context to context. Like GPT-4 is also a bulky model. Now, someone would ask, hey, why is Robota a bulky model for you? but it depends on the context. It depends on the requirements that your organizations might have. So what we realized is that the initial category classification model is kind of bulky, and then we decided to give it another try. Since we were optimizing for inference latency, it made a lot of sense for us to try to distill the model into something smaller. Because if you are reducing the number of flops as well as the number of parameters of a model, it should, in theory, run faster than a model which might have, a higher number of flops as well as more number of parameters. Like in most of the cases, it is the case. So we decided to also, distill our model A into something smaller so that it runs faster. And then in order to make the model run as optimally as possible on CPUs, we also optimized the model with ONNX, which is a fairly well-known execution provider, and also a model optimization toolkit in general. And we wanted to, step that up a little further. We also decided to quantize the model, like dynamic in-state quantization, very regular stuff, so that we can make use of all the optimized instruction sets that you get from your model Intel CPUs. So then problems started arising. So we had our distill model. Let's call that distill model model B, which we want to now deploy. Now, in order to get the maximum, in order to squeeze the maximum out of our Intel CPUs, we decided to quantize it using the dynamic in-state quantization mechanism. And then we saw like an accuracy drop of almost 60%. We were like, wow, what's happening? And then we again had to, dig deeper into the layers, how their activations were changing after we were quantizing the model. And it turned out that there was this activation function that we were using that was causing all the information to go away. Like it had a very continuous range. It had a very strict continuous range. And when we were quantizing the model, the discretization was causing a lot of these issues, and hence the model was incurring a lot of information loss. So what we did something very simple. So we decided to change the activation function of that model to something that didn't have those problems. We decided to change the activation from Swiglu to a Galeu activation function, if I can remember correctly. And then we again, ran the distillation pipeline. We again optimized the model with quantization, and everything was working fine. And we were able to reduce the inference latency of model A, the model that we had started off with, quite a bit. So optimization on CPUs, it's never a very easy business. You really have to approach things from first principles, and you really need to dig deep to figure out, ways and areas which you could improve so that your model runs as optimally as possible. Sometimes your models might be memory bound. Sometimes your models might be compute bound. So you really need to figure those things out to see which are the exact areas that you can work on so that your model runs as optimally as possible on the target hardware. So yeah, it was a journey, but I really enjoyed it.
It's very nice to understand that, because you mentioned different types of techniques about related to quantization. What I've been through here, I was trying to deploy as well, as Rodrigo mentioned, a Llama 70B parameters model. And when I was trying it for the first time, I went through a very challenging situation that was, okay, we don't have GPUs available. Everybody's trying to deploy the same model as me. It's what is happening maybe. And then I came to the quantization part, and it was available for me a lot of different types of quantization models, already quantized models, right? And I could also quantize myself using bits and bytes of the library that will run the quantization on the fly. Or I could go to a game phase and see already quantized models. And we started with the GPTQ, if I'm not wrong, the format, okay? Because we, for those who are listening to us, I don't know what it's going to suppose that we have the different types of numerical values here when we are working with models. We have the float 32, and we have the int 8. So I'm being very, very practical here. It's not like this. We have a very specific parts, technically speaking, but just to summarize, and when you lower the precision, you're supposed to have a more lightweight way to deploy these models, to run these models. You may face some impact in the model performance because you are lowering the precision of that, but you suppose maybe it is not going to affect or impact your production life cycle. So just being very, very practical here. And what I did, I was using the GGUF format. That's another way to quantize these models. It was already quantized, and it was very easy for me to deploy using this specific format. So that's a very different branch in machine learning. A lot of research running through the quantization, right, Sayak? So very nice to see you quantizing by yourself. You had to run the library, and you have not seen a model that you needed to use in your pipeline already quantized. So you had to quantize yourself using the specific libraries and different methods. But I don't know if you had to go through different methods before you selecting or electing the method that would work better for your use case, or you already went to the one that gave you the best performance, as well as not decreasing the performance that you needed for your model in production, because it's like a trade-off, right? You are lowering the precision of the things, but you also expect the model to give you the result that you need for your customers.
Yeah, I think we decided to use our intuitions a fair bit. Since we didn't want to do quantization aware training, we wanted to keep things post training, and we really didn't want to do FP16 inference on Intel CPUs, because we already had pointers that intake quantization it's gonna work the best on the Intel CPUs that we had available to ourselves. So yeah, we decided to just give it a try and backtrack things from there. And also, talking about large language models and running them on CPUs, I think in most of the cases, like where you have unbatched, whenever you have a need to generate text in an unbatched manner through a chat interface, most of the times the problem is memory bound. It's probably not compute bound. It's like every time your model needs to generate a token, it needs to load up all the weights in the memory, and if that process is slow, your generation speed is going to take a hit. And CPUs are not known for their memory bandwidth compared to what the beefy GPUs have. For example, an H100 has like 3 TB per second memory bandwidth, whereas a consumer CPU with a single RAM channel will have something like 40 GB, which is like orders of magnitude lower. So just get a CPU with more number of channels having more bandwidth, and if you are only in the territory of generating text in an unbatched manner, it should work. That should reduce your memory boundedness quite a lot, and that actually works. This is exactly why people can download billion parameter models on their laptops, quantize it with ggml or whatever, have some sort of a quantized and compiled representation, and do all sorts of things. Build a personal coding assistant, use it via VS Code, and so on. So this is exactly the reason why, because you are not bound to produce batched generations. I think it can still be worked around. And on latest MacBook chips like M3 Max, you can do quite a lot. So yeah, pretty interesting field, pretty exciting, and also it's pretty interesting to think how much accessibility is improved just by using quantization and a clever bit of compilation as well. So yeah, pretty interesting and fun stuff.
Very cool. And still on this kind of idea on how we handle it in production, I don't know for you, but I like to touch, what are the main challenges that you see within your day-to-day and in terms, I can share a little bit of what we see. Although we leverage most models, we do have a few models that we host ourselves and execute ourselves, but they're not LLMs by any chance. They're just smaller models to do classifications and some other elements like that, right? It's like next best action kind of AI elements, which is still problematic, right? You need the environment to run. But I think the biggest thing is how to deal with inaccuracies, at least on us. All the outcomes, how do we go in the direction of how do I try to narrow it down to answer what my user is expecting, even when we try to create interfaces or UIs that are not chat-like, because that is very open, but also very hard for you to scale as a company. So we create other alternatives, but still ensuring results, ensuring that AI will not change languages. That was a big surprise that we had that we're dealing with. Like sometimes we ask it to do things in English and just reply in Portuguese because there's some part of the prompt that was in Portuguese at some point. So it's kind of unpredictable, which is fun because I think we're talking early. It's good to have good challenges. So I think it motivates us. But on your side, what are you seeing challenges using these models in production? How do you see, and what are the main elements that you discuss on your day to day?
Like there are many sorts of challenges. For example, the unexpected outputs. Like how do you go about debugging the unexpected outputs? Like how much you can do with prompt engineering? Like what's the upper limit there? Can you do a lot more with in-context learning, like clever prompt engineering? Show your model a couple of examples and then prompting it to answer your question, as opposed to doing like a parameter efficient fine-tuning workflow and stuff like that. And if there's any sort of data contamination somewhere in your, I don't know, data set of 1,000 samples, it can contaminate the entire model. Like it has the potential to contaminate the entire model. So unexpected outputs has got to be like the number one thing that I'm almost always annoyed about. Like why my model is not generating what I'm asking it to generate. Come on, like put your focus there and do my thing and get shit done. Why are you not doing that? So debugging and approaching the solution process is almost always a very alchemy thing. It's more alchemy than science, I would say. Like there's no clear systematic and scientific process about it. It's always a bit of an artistic process, I would say. Like try lots of things, try lots of prompts, see if fine tuning helps and so on. So yeah, I would say getting unexpected outputs, like, and by unexpected outputs I essentially umbrella other terms such as hallucinations and so on. And then also unfair outputs. For example, if I ask it to generate a particular character, it generates the character, but probably not from the same ethnicity and so on. So these are hard problems, and no one is supposed to like feel bad about it. I mean, no, you are supposed to feel bad about it because it's giving you unexpected outcomes, and oftentimes you do not have a clue. Like it's not a scientific process, as I mentioned. It often relies on a particular token to make it go triggered and so on. So yeah, I would say this is the primary challenge.
That is interesting, and I think we're all now in some sort of way. I think large language models kind of demystified or democratized AI for folks, because it was kind of hard to not only understand but actually touch AI. Like you needed a lot of data to train, so not all companies could start doing that. So LLMs kind of democratize all that, but now everybody has to deal with similar problems, like what you're mentioning about how do I make the model do what I want and how do I debug if things go wrong. I think that's pretty interesting, because that's intrinsically what AI is all about, right? So it's explainability has always been a problem, so which kind of goes in that direction of why are you giving me the picture that does not represent what I asked you to do, or why did you reply to my question in this weird way. And it's fun. And you mentioned that is almost an artistic approach. I like that term. I'm gonna definitely copy that going forward. But can you explore a little bit on, okay, how do we start the process? It's about doing different questions or prompting the model in different ways to try to understand the elements that are triggering that reason, the reasons or explainability. How do you start that process of debugging it? Or
yeah, it also depends on the model that you're using. Like if you're using something like GPT-4, you are gated behind a closed API. There's very limited amount of explainability stuff that you can do with it. So like trying to probe the model in interesting ways, like for a particular set of input prompt, does it always provide similar answer, and so on. So if you provide more context in the prompt, does it provide similar answers, or does it improve, does it deteriorate, and so on. So like I think the line of work that introduced chain of thought prompting, I think it's pretty interesting because it forces your model to give you a reasoning about your answer as well. Like if let's say you are not getting the expected answers, you could also ask the model to explain it, like why did you arrive at that answer and how did you arrive at that answer, right, and so on. So I think knowing how to prompt your model in a better and more efficient way is a very good way to go about it. Like you will have to spend time with that, like nearly crafting a prompt and also like a dialogue that helps your model in the in turn. Like it, if better prompting, if let's say you have exhausted all your options when it comes to prompting, then the next step could be to just fine tune the model on the specific exemplars, like the instructions and the responses that you might have in your arsenal, and letting the model learn a bit from the exemplars that you may have, and then seeing if the performance is improving. If it's not, then there's probably a deep down issue in some of the tokenization pipeline that the model is using somewhere down the line. So usually with better prompting and a little bit of hand holding via fine tuning work. Yeah.
And I know
And
that
sorry, I also wanted to give away another thing that we also do, like making the model aware of the reality is also pretty important to reduce some of those unexpected answers and hallucinations. Like making the model RAG aware, like retrieval augmented generation, but with a regular static LLM, that also helps. So yeah, so three, always try to do as much as you can do with good prompting to fine tune a bit on a small set of data and see what happens. And third, RAG. Yeah.
and the reg will give you the a little bit more deterministic results, right?
It
So
should. It should.
yeah, it should. Yeah, and we also have the agents that we're exploring, function calling. So when building AI applications, right? Applications on top of AI, actually, you have to be sure that those models are probabilistic. So you cannot rely on this output. So this is very, very important to always state here. But one thing that is very interesting that we were talking about language specifically, but we have the large models which are not language focused. So one thing that is very interesting is because of the multimodality, and I believe that last year, 2023, was a year where the awareness year, where everyone were understanding the reach of AI. Okay, what do I do with this technology right now? So everyone was trying to understand and accomplish this knowledge, get vocabulary. And this year, 2024, is where people will start to think about, okay, where and how can I start implementing this in my pipelines, in my I don't know, the flow that I have in my company, or at least in my routines, but more in a more feasible way, more efficient way. So we go to the practical view of AI right now. And people or companies that started talking about AI last year, they may have started with language, and now they are exploring the image, video, and audio. And I know, Sayak, that you are the top maintainer of Diffuser's library. So I would like to ask you to explain a little bit, how is this Diffuser's library? How does it work? Is because it integrates text, video, audio. How it is for you, this routine? Because there is also a huge challenge to not just put language models in production, but it can increase the difficulty when it comes to images right now, right? So can you give us some of this point of view?
Which point of view do you need? What is the diffuser library, or did you have any specific questions around image generation in general?
I believe we can explore a little bit introduction of this library. How does it work? What is the purpose? How can it help people that is listening to us, and also the challenges that may have to face in your routine.
Yeah. So diffusers it's an open source Python framework providing easy access to state of the art pre-trained text to image, text to video, text to audio diffusion models. But we do also have masked image models. But consider this library as a toolbox to do all things image generation, image editing, image to image translation, like the regular image based stuff, and also video generation, animation generation, and audio generation to some extent. But we also provide all the necessary tooling in case you are interested to train your custom diffusion models, like fine tune from the existing ones or train one from scratch, and so on. So it's really like a toolbox, having all the programmatic interfaces for you to tinker around with pre-trained state of the art diffusion models, and also to customize and fine tune your own. So that's about the library, and we do provide implementations in both PyTorch and Flax. So that's one bit, and we also try to make it as accessible as possible. Like you should be able to run a large diffusion model on consumer hardware such as V100 without having to write hundreds of lines of code. So that's the kind of motivation that we have. We want to make it easy for folks to start with image generation, video generation, and so on. But we also have enough tooling in case folks want to stretch their arsenals a bit further and want to customize things. We provide all the tooling for that too. So that's about the library. Coming to the challenges. Of course, we have got a very broad set of audience. Researchers love us because of the customizability that we offer from the library, because of the hardware accessibility that we offer from the library. Like it's possible to run a 44 GB diffusion system in just a 16 GB GPU. We have got all the tooling from the library itself. So that's quite a bit of engineering work right there. So that's one. Researchers love us because of the customizability and the accessibility. The indie folks that want to customize things, they also love us. And so we are not like other diffusion UIs such as Comfy or Automatic 111, which cater a lot to non-technical audiences. Like absolutely no disrespect to non-technical audiences, but we do have a very separate set of audiences when it comes to serving them, right? If you do not know Python, then you will probably have a hard time using the library for obvious reasons. And that's what we try to make it clear. Like diffusers should be a toolbox on top of which people build really amazing and cool things. But you really need a certain level of technical expertise to be able to do that. But yeah, of course, UIs like SD Next, then you have Invoke. They build on top of diffusers, so it's absolutely possible to build UIs on top of diffusers as well. So yeah, that's about the audience. Challenge wise, it's always a bit of a needle in a haystack kind of a situation, because every other day there's some new technique coming up in the diffusion community, and we really need to use our understanding to see probably not worth integrating the new technique into the core code base of the library and so on. So we do also have mechanisms to support custom pipelines without having to touch the core code base of the library, so that people can still leverage all the good features of the library without us having to change anything in the core code base. So that's also possible with the library. So yeah, that's about it. Yeah.
Cool, very cool. And how do you go to use it? It's an open source element, so that I can just hop in, get started using?
Yeah.
Awesome.
It's completely open source.
That sounds fun.
It's very interesting because we were talking about challenges in production. So putting images, videos in production, it's challenging as well, because you are dealing with data that's supposed to be even larger than we are dealing with text when we are training, when we are at different times. So it's very nice to see that you are being able to work with that and share your knowledge to the community, right? So yeah, as part of your daily routine. So getting to that point specifically, I'd like to explain a little bit about this topic, that is the open source, because open source has been helping you since your journey as a ML engineer, I believe, because within your article about the car that experience you had, you worked with some features from Hugging Face, right? So Hugging Face datasets, Hugging Face Hub, you work with the models, you hosted your model there, and now you are part of the features that are being integrated to Hugging Face as well. So it's the other point of view, right? You were in the client side, now you are part of building it. So I would like to explore a little bit with you, how is it for you, this experience, and how the open source community have been helping you in your life, not just the technical part, but also the other ones that are very interesting as well to explore.
Yeah, sure. It's a very favorite topic of mine. So again, I'll go all guns blazing. I like to consider myself as an internet taught developer, not even self taught, internet taught developer. So I've been benefited by the community a lot, like the open source stuff, like educational materials, the libraries that I get to use in a day to day basis, and so on. All of those things have a very profound impact on me, and I always try to give it back in my own ways. Of course, I probably won't be able to match whatever I have received from the community, but I can still do my fair share, not even fair share, let's say my tiny share. So I think it has been pretty exhilarating as far as the experiences go. I have interacted with folks from all across the globe. I have had the opportunity to read through their code bases, sometimes extremely cleanly written, sometimes not so cleanly written. But yeah, at the end of the day, I have had the opportunity to learn from their code, use their code to do something meaningful for myself. But also, as a part of my job, I get to review code that's of extremely high quality, and I get to learn from them too. And I think, coming to the point on the importance of open source, I think like it gives you an opportunity to build a solid portfolio for yourself, but also in a very organic manner. Like you are not hacking into something, some objective to to accomplish yourself in your life. It's like it also gives you a fair amount of confidence, right? Because when you are contributing to an open source library, let's say the nature of the contribution is very non-trivial, then there's no supervisor guiding you. It's all you, right? You have to be disciplined enough to be able to complete a certain pull request. You need to take all the feedback from the library maintainers, apply them in a salient way, and get your feature merged. And if your feature is getting used by thousands and thousands of folks, you already have something to show to your prospective employers. It's a shame if the employer cannot fathom the depth of your open source contributions, I must say, because I hate it when recruiters do not like to pay respect or pay importance to your years of open source work. I think it's definitely a sad situation, but huge respect to the recruiters or employers who have a knack to consider your open source contributions too, because if they do, they already have a sense of how you code, how you go about thinking about a particular problem, how do you communicate all the nitty decisions that you are taking while writing a piece of code, and so on, just by seeing your pull requests, right? So I think, yeah, that way it's pretty important because it already gives you a fair amount of edge over the other candidates who may not have non-trivial open source contributions. And in my life, open source contributions have given me a lot of things, like a very good organic networking. Like folks have reached out to me saying, hey, I referred to your code and it helped me a lot. Some of them have reached out to saying, hey, probably your code is buggy and you should fix it. Again, that helped me improve my code at the end of the day. So I take it in a fair share of spirit. Like there are not everything that's great about open source. Of course, like there's a lot of noise. You have to really have a patient mind and a salient mind to be able to filter through the noise. But I think with enough experience, with enough patience, you anyone can do that. But yeah, I like to not emphasize on the on the cons of open source. Rather, I like to uplift the strengths and all the pros that come with open source. So yeah,
That was a very passionate conversation, which I quite like, especially because when we're talking about models now, we basically have two options, right? Or we go with the more closed models, like you mentioned, GPT is one of them. Gemini is another one. Claude now that seems to getting a lot of attention since their statement this week about how their models are kind of executing, which is interesting because seems like the proprietary models, the more closed models are, I don't know, I'm going to say larger and more capabilities of reasoning versus open source models that are more open to fine tuning and open to further evolution and all of that. Do you feel that that's the scenario? How do you feel about the difference between open source models versus proprietary models in that sense? And do you see specific niches where it might make sense to apply one or the other?
I think it entirely depends on the organizational context. Like if you don't have the machine learning cavalry within your organization, it might be very difficult for you to set things up from scratch, hire a bunch of specialized folks to do your job for you. But if you are in like model training business, then probably it makes sense. If you are not in the model training business and if you can't afford sophisticated or dedicated machine learning engineers who can make sense out of the open source models and derive a dedicated pipeline for you, then probably closed source. Give closed source a try. Build your business. Once you have a revenue streaming, then you could probably set up a team and consider moving to open source. That's what my take is.
Oh, and any other advantage that you see on kind of you going to the open source route that would not be like cost savings or anything like that? It would be more related to how I can leverage that to my business from your perspective.
You have access to the model. You can download the model weights. You do not have to rely on internet connection and so on. So network bandwidth is one. Second, you can probe the model. You can see exactly what's happening in the model code and change the bits you do not like and take things from there. You can do all sorts of stuff like quantization, which you can't do on your closed source model. And yeah, you can basically have a lot of ground for experimentation with an open model, which you may not have with a closed model. That's what my take is. And if you already have the engineering knowledge, then you should be able to scale the model. You should be able to meet with the challenges and go about solving it in your own ways. So yeah,
pretty cool. Thanks for that insight. I agree a lot with you with the closed model versus open source. I think closed models are a good way for most people to start because it takes a lot of the complexity away. And if you're like me, 20 years of engineering, creating microservices, e-commerce and all of that, and doesn't have a clue on how to start all this, it's a good way to start. You can actually use large language models to learn about AI and then go the open source route, so which is pretty cool. Exactly. Kind of inception moment that you can have with these models.
Yeah.
Awesome. Sayak, this was an amazing conversation. We were heading down to the end of our conversation here. I really like to thank you so very much for making your time available and connecting with us from Brazil. It's very nice to speak with you, and I like the global reach that we're talking from US, Brazil, and India right now, which is pretty fun. So thank you so much. If you like any final words, please go ahead.
No, I'll just repeat myself. It feels exhilarating and very special to talk to friends from Brazil, because one day, I don't know, I'll get to play football in Brazil. Although I'm not a footballer myself, I grew up playing cricket because cricket is very popular in India as well. But yeah, it genuinely feels special, and thanks for having me.
Cool. Thank you, Sayak, for being with us. Thank you, Rodrigo. See you next episode.
All right. Bye.